The Shuttle Orbiter is a versatile, multi-purpose spacecraft designed by NASA for repetitive flights into low Earth orbit. The phenomenon of riding this unique vehicle into space will be experienced by men and women from several nations during the 100-mission life of each orbiter. The crew compartment of the vehicle provides living and working space for 7 persons on missions lasting up to 30 days. In this shirt-sleeve environment, crew members work on a long list of objectives to be accomplished on each flight. Storage racks on the mid-deck level usually contain several mission experiments. Other experiments and payloads are carried in the 60-foot long, 15-foot diameter cargo bay. Small experimental canisters are usually mounted on the sides of the bay. Larger cargo packages may include Space Lab modules, a space platform, a huge telescope, or a number of satellites. The orbiter serves as a launch platform for equipment which must be boosted into a higher orbit, such as communications and weather satellites. An upper stage PAM engine is ignited about 45 minutes after release to boost the satellite into a synchronous orbit of 22,300 miles. Mission specialists use the Canadian-built remote manipulator arm for a number of payload-related tasks. Scientific equipment and satellites can be lifted out of the cargo bay for deployment in low Earth orbit. Other equipment, including malfunctioning satellites, can be retrieved from space and placed in the cargo bay for repair or return to Earth. When necessary, shuttle astronauts may move outside the crew compartment to inspect equipment, make repairs, or conduct experiments. Several hundred persons may eventually work in space aboard each shuttle during the spacecraft's useful lifetime. The shuttle astronauts will soon be performing unique jobs and experiments in space which, until recently, were only dreams in the minds of men on Earth. Repetitive use and short ground turnaround time for each orbiter is a shuttle program requirement. Even as an orbiter nears the end of one mission, the major components for its next mission, including fuel tank, booster rockets, cargo, and crew, are ready and waiting for launch from Kennedy Space Center. The flow of shuttle hardware and cargo through inspection, testing, and launch at Kennedy Space Center is a continuous process. Shuttle flow, an efficient, standardized process, assures the simultaneous readiness of a multitude of components for each shuttle mission. The process begins with the arrival of each piece of shuttle-related hardware at our nation's spaceport. Some components are delivered by large cargo aircraft. Others arrive on ocean-going barges or specially designed railroad cars. Work on one hardware item begins shortly after launch of a space shuttle. The burnt-out casings of the shuttle booster rockets separate from the orbiter 2 minutes after liftoff. Parachutes slow the descent of the casing to an ocean splashdown. The spent casing and its parachutes are recovered from the ocean by crews aboard 2 retrieval ships. Once the parachutes are hauled aboard, divers undertake the task of placing a plug in the bottom of the rocket casing. Air is pumped into the casing, causing it to float on the water. The floating unit is towed to Port Canaveral. The AF facility at Cape Canaveral is the processing area for the spent booster rocket casings. Each casing is first moved through a high-pressure wash cycle. Following cleaning and safing, work crews dismantle each casing to the level of its major elements. Some parts are refurbished here for use on future shuttle flights. The 4 fuel sections of each casing are prepared for shipment to Utah, where they'll be refilled with solid propellant and returned to Kennedy Space Center for reuse. The parachutes recovered from the ocean are delivered to another facility at the Space Center. The 115-foot diameter main parachutes are hung systematically on an overhead monorail. The chutes are moved to an inline washer and dryer where they're cleaned and dried automatically. After inspection and acceptance, the chutes are repacked for use on another shuttle mission. Several weeks before a scheduled liftoff, the parachuted package is delivered to the vehicle assembly building for installation into the frustum, or nose cone, of the booster rocket. Segments of the booster rocket loaded with solid fuel are delivered to the solid motor storage building. Each segment is carefully removed from the specially designed railroad car used for transportation from the fuel plant in Utah. The segments are stored in this area to await transfer to the vehicle assembly building, where they're joined together to form the booster rocket. The external fuel tank for each shuttle mission is delivered to Complex 39 by ocean-going barge. The 154-foot-long tank is the only major component of the shuttle system which is not reused. The external tank is moved into the low bay of the assembly building for inspection and storage. The orbiter is usually the last shuttle component to be received at the spaceport. At the completion of most operational missions, the orbiter will touch down at the spaceport's 3-mile-long shuttle landing facility. If the orbiter does not land here, it'll be delivered to the spaceport aboard a 747 jet transport. Following landing, servicing, and unloading of certain cargo packages, the orbiter is moved to the orbiter processing facility. The 10-story high OPF has dual high bays capable of handling 2 orbiters in parallel flow. Analogous to a sophisticated airline hangar, the orbiter processing facility is used between flights as a service, inspection, repair, and test area for the orbiter. The 3 main engines of the orbiter may be removed and serviced in the OPF, and many functional components of the orbiter checked for proper operation. The 2 doors of the orbiter's cargo bay are opened to unload experiments from previous missions and to load equipment for the next mission. The large cargo packages loaded aboard the orbiter in this building are referred to as horizontal payloads. They're loaded while the orbiter is in the horizontal position. Other payloads, known as vertical payloads, are loaded aboard at the launch pad when the orbiter is in a vertical position. The Canadian-built remote manipulator arm is installed in the cargo bay if the arm is to be used on the upcoming mission. The arm is a versatile tool used in space to move cargo packages about or to deploy or retrieve orbital payloads. The cargo to be carried on a specific shuttle mission may be delivered to the Space Center up to several months or just a few weeks before the scheduled liftoff date. All cargo is processed and tested offline from the launch vehicle prior to loading aboard the orbiter. There are 8 vertical payload processing facilities near the launch site. 7 of them are located on Cape Canaveral and the other at the Space Center on Merritt Island. Each assigned checkout area is dedicated to 1 cargo package from arrival of owner-furnished unique items of ground control equipment until launch. An extensive effort has been made to achieve commonality of major equipment items used in processing payloads. Field teams from the owner, builder, and operator perform the assembly and checkout functions for their particular cargo with support from Space Center personnel. At any given time, one may find Indonesian technicians preparing a Palapa communications satellite for launch, or German scientists working on experiments to be installed on the SPAS space platform. Small experiment packages, known as getaway specials, are checked out by the owners. The getaway special canisters are used by industrial firms, educational groups, and others to place small experiments into orbit. Users of the canisters include university and high school students, medical research firms, a seed company, and a Japanese newspaper. The cost of orbiting the canisters is paid for by the owners, as is the cost of launching larger payloads aboard the shuttle. Certain shuttle payloads, such as communications and weather satellites, must be boosted into a much higher orbit than that of the shuttle orbiter. An upper stage rocket is attached to each of these satellites in one of the safe facilities at the Cape. This PAM upper stage will boost the satellite from the 150-mile-high shuttle orbit to a geosynchronous orbit of 22,300 miles. Each of the vertical payloads undergoes final checkout in the vertical processing facility at KSC. The Pac-Man type covering around this satellite is a thermal cover to protect the payload from solar heat prior to being launched from the orbiter cargo bay. The payloads are stacked according to their designated position in the orbiter cargo bay. A series of tests are conducted to verify operation of the components and to verify mechanical fit and electrical compatibility between the payloads and the cargo bay. At completion of testing, a transport canister is moved into the building. Each payload is now carefully transferred to the canister for transport to the launch pad. The environmentally controlled canister provides all needed electrical, gaseous, or mechanical protection required by each payload during the move. The 7-story high canister rides to the launch pad aboard a 48-wheel self-propelled truck. The vehicle was specifically designed for transport of shuttle cargo. At the launch pad, the canister is maneuvered into position below the rotating service structure. The service structure contains a cargo changeout room which has movable service platforms to accommodate various payload configurations. The canister is raised and temporarily attached to the structure. The payloads are transferred from the canister to the cargo changeout room. At the completion of this operation, the canister is removed from the launch pad. The operations and checkout building is the processing area for the second type of shuttle cargo, the larger horizontal payloads which follow a different route to the launch pad. The entire high bay of the O&C building has been converted into the horizontal integrated checkout facility, where all work is performed under white room conditions. The European-built Space Lab is the primary horizontal payload. Components for several different Space Lab missions could be processed here simultaneously. Space Lab is a versatile laboratory utilizing modules and pallets which can be varied on each mission. The pressurized modules are designed as working areas for the orbiting astronauts and can be equipped with a large number of experiments. The pallets are installed behind the module and carry various experiments which must be exposed to the space environment during the mission. Individual consoles containing several different experiments are loaded into the pressurized module to form the experiment configuration for each mission. Astronauts and mission specialists work with Space Center technicians in checking out each of the experiments aboard Space Lab. At the completion of the assembly and checkout, Space Lab's modules and pallet are lifted and placed into the transport canister in a horizontal position. The 48-wheel truck is used to transport the canister and horizontal payload to the orbiter processing facility. The orbiter's cargo bay has been prepared to receive the large horizontal payload. Space Lab is carefully lowered and positioned in the cargo bay. In the following days, additional tests of the payload and orbiter are conducted. Finally, when all components are ready, the doors of the cargo bay are closed and locked down. The orbiter is moved from the processing facility and rolled over to the vehicle assembly building. The booster rockets and fuel tank have already been erected on top of a mobile launch platform. Now the orbiter is raised using special lifting devices. spacecraft is maneuvered into position and mated with its external fuel tank. The completely assembled shuttle vehicle undergoes electrical and mechanical verification tests in the high bay. These tests are controlled from consoles located in the Launch Control Center. 2 firing rooms in this facility have been equipped with the highly automated launch processing system, which controls and performs much of the shuttle vehicle checkout automatically while the various components are being prepared for launch. This system is also used to conduct the launch countdown. Several days before the scheduled liftoff, the fully assembled shuttle is moved to the launch pad. A mammoth tracked vehicle, the crawler transporter, balances and moves the mobile launch platform and shuttle space vehicle along an 8-lane wide roadway. The 3-mile trip to the launch pad requires 8 hours. After the shuttle and its launch platform are in place on the pad, the rotating service structure is moved to enclose the orbiter cargo bay. The service structure provides clean room access to the cargo bay of the orbiter. Vertical payloads are loaded aboard the orbiter at this time. They're transferred from the service structure to the orbiter's cargo bay. Horizontal payloads already aboard the shuttle undergo final ground checkout by technicians. As the scheduled launch day approaches, a 40-hour countdown is begun by the launch team in the firing room. At T-minus 11 hours, the rotating service structure is moved back from the orbiter. Propellant loading of 140,000 gallons of liquid oxygen and 380,000 gallons of liquid hydrogen begins at T-minus 6 hours. The beautiful and tranquil scene of the shuttle on its pad belies the hazardous operations involved, which require carefully controlled access to the area during launch preparations. During a countdown hold at T-minus 2 hours, the astronaut crew prepares to board the shuttle space vehicle. Pressurized flight suits are no longer required for shuttle flights. A special helmet is worn during the liftoff and landing sequences. After boarding the orbiter, the astronaut crew take an active part in the final minutes of the launch countdown. A few minutes before liftoff, most work at the Space Center is put on hold. Spaceport personnel step outside their work areas to watch the liftoff of the vehicle and cargo which they helped prepare for flight. Thousands of visitors to the Space Center line the causeway south of the launch site. At another location, hundreds of VIPs await the moment of liftoff. At most shuttle launches, thousands of cameras belonging to visitors and representatives of the world press are aimed at the shuttle during the final moments of the count. The 3 main engines of the orbiter are scheduled to ignite at T-minus 6 seconds and build up thrust. At T0, the 2 solid booster rockets ignite and liftoff begins. Within 2 minutes, shuttle reaches an altitude of 25 miles. The used-up solid boosters are jettisoned. As the huge casings fall toward Earth, A series of parachutes are released to slow the descent. The casings will splash down in the ocean about 60 miles east of the launch site, where they'll be recovered for reuse. 8.5 minutes into the flight, the external fuel tank is separated from orbiter. The external tank disintegrates as it falls through the atmosphere into the Indian Ocean. Within minutes, the crew experiences the weightless environment of spaceflight. Each of them soon becomes familiar with such techniques as floating down to the mid-deck. Crews flying aboard missions with the Space Lab move through a tunnel into the lab to begin a long list of experiments and work projects. Space Lab experiments are manned 24 hours a day on a 2-shift basis. On many missions, pressure-suited astronauts work outside their spaceship. On repair and construction missions, personnel use a chair-like backpack to propel themselves away from the comparative safety of the orbiter's cargo bay to work and function alone in space. No matter what the mission is, all crew activity is monitored and recorded by personnel at Mission Control in Houston, Texas. Shuttle experiments also are monitored here and at other locations where scientists, students, and businessmen meticulously scan the data received from their equipment operating aboard the orbiter. While the personnel in space and those at Mission Control carry out the extensive work of the orbital mission, workers at Kennedy Space Center continue to prepare for the next mission and those to follow. The flow of shuttle hardware and cargo components continues throughout the Space Center. In another week or another month, everything must be ready for the next shuttle mission. The dedicated personnel at America's Spaceport proudly carry out their routine but highly specialized work of preparing and launching each vehicle in NASA's Space Shuttle program.